folks, could everybody see and hear me? Please raise your hand if you can. All right, wonderful. So obviously, Mr. D is not back today. This is Ms. Saunders once again, here for another excellent webinar. I hope you all had a great weekend, and so I suppose without further ado, we shall get started. So last class, we worked on 123D Design, which is a 3D modeling software. We're actually going to switch gears now. This class, we're going to be working with software called 123D Make. It's made by the same guys who made 123D Design, and you can actually import certain designs from that you make from 123D Design into 123D Make. 123D Make is really nice because it lets you turn 3D models into two-dimensional building plans with assembly instructions. So let's think about it this way. We can take a whole bunch of cardboard or metal or anything we can laser cut and assemble that to take this two-dimensional thing and make it into 3 dimensions. So I'll go into that in just a moment here. Before I get started, is there any questions based on the crash course in 123D Design that we did last week? All right. I will go ahead and get started then. So today we're going to use 123D Make. We're going to learn how to navigate 123D Make, get our first print started, and we are also going to learn a little bit about laser cutting. So let me see. I see a question. Do we need to download anything today? I will be giving you something to download, in fact. And while I'm lecturing, I'll probably give you the link right now. That sounds like a good idea. So we're going to be using, we're going to need to go to this website to download 123D Make. I will send the link to you in the chat box as well, so that you are able to access it. But yeah, what I want you to do is go ahead and click on that link or type in the URL so we can get the download started. What's cool about this software is that it's available for Windows, Mac, and for iPad and iPhone. So a lot of softwares haven't been compatible with, the iPad or iPhone, but this one is pretty cool stuff. 123D does a lot of stuff making apps compatible for iPad, which is really nice. So obviously I do want you to click on whichever one of these that corresponds with your computer. I'm a PC, but go ahead and click it to start the download. I see a question. Here's downloading. Okay, great. That's what I'm looking for there. I haven't found any issues yet today in my other webinars with downloading it, except for slowness, which does happen when you're downloading something. A lot of RAMs being used while you're on both GoToWebinar and any software we use. And so I'll go ahead and tell you a little bit about laser cutting while we're waiting for that to download. Once it is downloaded, go ahead and open it up just to, sort of get the ball rolling here. So I'm going to start with an intro to laser cutters. Or I see a question first. Do you know when Mr. Dubik will be back? He was supposed to be back tonight. He's not because he's helping me out with one of my labs for the next week. So I know it's weird having to switch from teacher to teacher, but Wednesday should be the day. But I can't guarantee that. It won't be me it won't be me this coming Wednesday. So yeah. Anyways, laser cutters were first developed in 1965 when they were used to cut holes in materials such as diamonds, which were previously very, very difficult to cut. It is one of the hardest materials or on planet Earth at least. There are a couple different kinds of lasers around today. The most common is called a carbon dioxide laser. In the context of these laser types, carbon dioxide is the specific type of gas that is pumped through the laser's head. And I'll show you what that means in just a second here. Laser cutting also has more precise and versatile cutting than a bunch of other different methods. So laser cutting is very handy or laser cutter is handy to have around, I should say. So laser cutters work by creating a beam of light, which will soon be called a laser. This light will be bent and bounced around until it's very focused, which is the laser part. It is then more further focused with lenses just like the ones that are in your eyeglasses. It then heats the metal that you are cutting and cuts. Now the gas comes in at a certain spot in the nozzle of the laser. Gas is pumped in there to either blow away chips of metal that may appear around the cutting area, or it can be ignited to get the laser even hotter than it already is. That way it'll help cut through very tough surfaces to cut through. So it's very clever how it works. There are also many different kinds of laser cutters. The first type is a vaporization cutter, which essentially only melts stuff. What's the part in the laser that makes it bad for your eyes? It's actually the light beam itself. The light beam in a laser is very, very focused, so that all its energy is on a certain point. So if you look at a laser pointer directly, all of that energy in the form of light is going directly into your retina, which will burn it. So that's why lasers are not good to look into. In a couple words. So the next kind of laser cutter is a melt and blow, which is what I was mentioning earlier with the carbon dioxide. It'll melt whatever you're cutting and then blow all of the chips away with air, not with explosions. There are no explosions in laser cutting, ideally. The next type is called thermal stress cracking. You heat it up, and instead of cutting it, it just makes cracks. So that's actually used for glass. Like if you see a laser etched glass, like your parents might have one, that's what they do for that. So it's not quite breaking it or cutting it, it's just making sort of a design and indentation. The next type is a stealth dicing type, which is used for computer chips. Do laser pointers contain heat like a laser cutter? That's a good question. Laser pointers, when I say energy, light and heat are both types of energy. So laser pointers do contain energy, which can be translated into heat. So if we have a more powerful laser pointer than, one of the red ones, so say we have a green or a blue one, there's a lot more energy focused in the laser beam in one of these more high power lasers. So while it doesn't contain heat, the energy is enough to heat certain objects. If your 123D Make is finished downloading, go ahead and open it. Can lasers pretty much cut anything? I wouldn't say anything. It really depends on how much energy that is powering the laser. And by powering, I mean, when I say power, I mean you have to have a certain amount of power to translate into light, to translate into heat. Does that make sense? They can cut almost anything, but laser cutters are still very, very small scale compared to, like, I don't know, the Death Star. So, interesting question. Stealth dicing is for computer chips, for really small stuff. I don't know why it's called that, even though it's a cool name. And then reactive cutting for thick metal. So, can lasers cut pretty much anything? Laser cutters can cut pretty much anything within reason. Now, lasers depend on the energy input to cut anything. So laser cutters are pretty nice because they're relatively cheap and relatively easy to use. Obviously, you'll need to have money and a little bit of training to be able to use one of these for the most part. It can make very, very tiny and very specific cuts, up to 1 millimeter thick, or 0.1 millimeter thick, which is way tiny. And it can be used on many materials, such as glass, metal, cardboard, and wood. What we've done so far with 123D Design, we've looked at some 3D modeling, which is good for using a 3D printer with and a CNC machine with. A CNC machine being a computerized machine that can read in vectors to machine them. So a lathe or milling or even a laser cutter can sometimes be a CNC machine. But what if we only had cardboard or just a very basic laser cutter and we wanted to make something 3D? And that's where we get into 123D Make. So 123D Make uses 3D models. You can import the models that you create actually from 123D Design and then use 123D Make to 2D print them and assemble them into 3D designs. What this software does is slice up the model into a bunch of different layers, places all these layers on a flat plane, so sort of like, printing on a piece of paper, which you can then cut out and put it together. So you can either cut it out on your own or get a laser cutter to print it out. The software lets you do either. So it's pretty cool because if you don't have a 3D printer handy, you can ask mom and dad to print some stuff that you make in here and you can assemble it on your own. So it's cool stuff. Do you mean if you add a photo, it adds it as 3D? No, I do not mean that. You'll need to start with a 3D design, and then it will make it into a two-dimensional design. So it's like a reverse 3D printer, kinda. It's a reverse 3D printer that you then have to build to make in 3D. It's as if a 3D printer printed out a bunch of slabs, sort of like this rhino here. These slabs are flat, but you have to assemble them into it and make them three-dimensional. And I'll show you what that means in a second. It sounds a lot more complex than it is. It's sort of like origami in a weird way. So I had you download this. It should be either downloading or very close to finished. Now, I do need you to download one more thing. The link that I'm sending you right now in the chat box. Actually, I see a question real quick. Oh, come on, what are you doing to me? So you have to make like thousands of sheets of paper. Not necessarily, they can put more than one object per sheet of paper. But if you have a complex enough object, yes, it'll be thousands of sheets. Yours downloaded, but you can't pull it up. What's saying when you try to pull it up? While you answer that, Cooper, I'm going to send the link to something in the chat. This is a direct link, meaning that once you click it, it will immediately start downloading. It is a 3D model of a T-Rex. We're just using this as an example for today. And let me know if you have trouble with this link. So you're having issues pulling it up. Is it giving you an error? Is it just not starting? There's a lot of different things that could be happening if you're having trouble opening it. And also, while you answer that, I do want you to raise your hand once you've started downloading this dinosaur file. Yours not doing anything, you see numbers and letters. Alright, there is another website for this. This is the direct link to the Instructables page, which does very similar things to what we're teaching today. You will need to scroll down with this link, and you'll see a blue T-Rex, and the file will be called 2304 T-Rex something if you're having trouble with that direct link. Alright, so I sent you a link in the chat box, and it seems like a lot of you are just getting straight up code. The link I'm sending you now is the link to the Instructables page for it. Now it might say something telling you to sign in, just X out of it. And scroll down until you see this blue T-Rex. That link still gave you code? It really didn't take you to the web page? Huh. Alright. Well, never mind the link then. There are some already made models in this software that we'll use instead for yours. I'm going to use the T-Rex because it looks cool. But I'll show you how to get to models that are already contained within this software. You can't find 123D Make in your downloads. I'm assuming you did download it, or else you wouldn't probably ask me. Could you try searching for it? If you're on a Mac, it'll be via the Finder in the upper right. If you're on a PC, Windows 10 will be at the bottom left. Or I think even the top right, because it just wants to make it confusing for you. You will not need to sign in to either 123D Make or to the Instructables page. Right now, at least. We might need to later, but you already do have an account from 123D Design. Cooper, I'm just going to say keep looking for it. If you downloaded the link to it, or if you downloaded the installer, it should be floating around somewhere. And once you open it, you'll need to accept the license agreement, to which we say, sure, yeah, we agree. But again, please raise your hand, keep it raised when you have gotten 123D Make opened. To download the T-Rex, which you don't have to do, but you can if you want, the link to it is this Instructables link. If you X out of the pop-up and scroll down, there will be this blue T-Rex standing on its tail. The link to download this T-Rex standing on its tail is right above it. But if you can't get this downloaded for whatever reason, I'll show you an example pattern that you can use instead. So you'll see something that looks a little bit like this on your page, very blank. Might notice a few familiar things. To those of you with the T-Rex, what I would like for you to do is click on Import in the upper left side of your screen. This T-Rex will be wherever your downloads folder is on your computer. And go ahead and open it. It'll take a second, don't fret. If you don't have the T-Rex, what? Where's the option to import your T-Rex? Yes, I'll show you one more time. We've got 123D Make opened. On the upper left, there will be a tab that says Model. We then click on Import. And find the file for our dinosaur, which should be a file that says FXTOWR or WKR. I can't even read it, but it's a really long uppercase name that we'll select and then open. If you didn't download the T-Rex, if you can't find it, you're going to listen to my instructions right now then. If you don't have the T-Rex, I want you to hover over this Autodesk 123D Make and scroll down to Open Example Shapes. I then want you to click on Rhino. So if you have the T-Rex, open the T-Rex. If you don't, open up the Rhino example shape. if you have the T-Rex opened, you might notice that it's standing on its tail, and it's kind of funny looking. If you would like to rotate your T-Rex, which you probably should, if we go to the top left of our screen and find the model box, oops, there will be an arrow that is in a circular sort of manner here. You just click on that once, you'll be fine. It'll put your T-Rex where you want it to be. I want y'all to remember that this is not a CAD software. This is not a CAD software like the one we've used before, so we can't do much to change this 3D model beyond what the software can do. So, what do you want me to do again? Or was that an old question? Well, I can always show you again in a second. So take a second to figure out the controls of this software. They are very similar. In fact, I think they're almost identical to 123D's controls. If you right-click your mouse, you can rotate your view. Middle click will let you pan. And using the scroll wheel on your mouse will let you zoom in and out. You'll recognize this nav cube, this navigation cube. And you'll recognize the first three options on your upper right, which are underneath the navigation cube: rotate view, pan, and zoom. There are two new options though underneath. The second from the bottom is the center on page, which is completely unsurprising what that does if you click it. It just centers it on your page. The bottom option lets you change your projection. It gives you slightly different views of your object, which may help you when we go to the next step. So don't worry about this right now. You may never even need to worry about this, but it's up to you. So the first thing I want to show you is the Object Size tab. So skip this Manufacturing Settings tab for now. I'll show you what that does in a minute. The Object Size tab shows you literally the exact size of the object you have imported if you were to print it. The default units are in inches, but you can change that to feet, centimeters, millimeters. Let's keep it in inches because this is America. Also notice that once I click that, something pops up over here, a new set of tabs. Don't worry about that for now. By default, we have the uniform scale option selected. The uniform scale option will let you change the height, let you increase the height, but will increase the width and length so that the overall shape stays the same. So it's just blowing it up or making it smaller. The original size option, though, will make your object its original size by default. which in this case for the dinosaur, I don't know about the rhino, is pretty darn large. For the dinosaur folks, we're going to need to scale this to make it smaller in a couple minutes here. But we won't worry about that just yet. I now want to show you the construction technique. This tab is really the bulk of this software. I want you to take 1 or 2 minutes to click on Select a Technique and check out the differences in between these different options. So I just want you to go ahead and see what happens when you clicked on Stack Slices. Ignore any errors that may pop up. Let's just see what happens when you select Interlock Slices and all the way down. I do want you to raise your hand and keep it raised once you've checked all of these out, and I'll go over a little bit more about that in just a second here. Because they all do something different. All right. So some of these obviously look better than others, especially for the dinosaur. It does not look good at all with interlock slices or curved. But I'll just go over what these do real quick. Stack slices literally will let you stack slices on top of each other. Interlocked is sort of like building a building. It'll take the most important parts of your object. They look like weird aspect folded panels. That looks cool. That's actually exactly what that is, and give me just a second to explain. Interlock slices just give you the more important parts of your object. Oh, okay. Well, I'll still talk about that in a second. Curve has sort of a curved aspect to it. Radial slices will slice based on one center point. 3D slices, which are obviously the best looking, are generally not practical for your use. So even though it looks the best, we won't use it. And the last one is the folded panels. Now, folded panels does not create slices like the other ones, but it makes one huge flattened panel. So if you are familiar with what's it called? Papercraft, which is sort of like origami except it involves you cutting and folding along edges to make shapes. That's what this is. It's sort of like old school polygons in video games. If you're familiar with N64 style graphics, that's what folded panels does. So good for Halloween costumes as well, if you have a printer that can print big enough piece of paper. But we're going to want to select stacked slices for now. Because it's probably going to look the best. It still looks weird, but don't worry, we'll work on that. So now I want to focus your attention to the right side of your screen. There are 2 tabs, Cut Layout and Model Issues. Right now we have 0 sheets, meaning that we're not ready, it's not going to print. There are 0 sheets of paper we've made ready. And parts, 239. That's a whole lot of parts. That's every single individual slice. There are 239 of these. So if you're using the Rhino, it might be a little bit more or less, but regardless of which design you're using, we want to make the slices a little bit different. Right now we've got horizontal slices along the length of the body, but we want to have vertical slices along the length of the body. A couple different reasons. A, it will look better. Let's be real. And B, there will be fewer parts. So what I would like for you all to do is click the icon next to Slice Direction. There may be a pop-up next to Manufacturing Settings. We'll fix that in just a second, so don't worry. Let's just click on the icon next to Slice Direction. And what will pop up is, or are a couple of circles around your dinosaur / rhino, whatever it is. What the slice direction does is it changes the slice direction. Surprise, surprise, right? In this case, what we're going to do is change the blue direction. So what we need to do, once we've gotten this selected, is click once on the circle surrounding this object, and at the bottom of your screen there will be a rotate by angle button. I need you all to change this angle to 90 and hit enter. Oops. So what that does, it'll change those horizontal slices into vertical slices along the length of the dinosaur. And so, good point. I see your T-Rex says 1 sheet, 99 parts, or it's not working. And that's where we can change the manufacturing settings. So yours might be a little bit different than mine depending on your design. If we go up to the manufacturing settings option though, the default's going to be letter, which is what your printer will print out at home. To make this look a little bit nicer, let's scroll down to B1. And select that. So try doing that same thing. The slice direction is not working for you. Alright, so you made sure you have stacked slices. You made sure you've clicked on your blue axis once. And at the bottom of your screen, rotate by angle 90, and then hit enter on your keyboard. If it's not working still, let me know and I can help you figure it out. I do want you to raise your hand once you've gotten your T-Rex or Rhino having cuts that look like this, vertical cuts along the length of the body. Your Rhino is vertical, So you got it to look like this, or is your Rhino looking like this? If it's looking something like this, you will need to go to the top left of your screen. Underneath this eyeball, there will be an option that says rotate. And I just want you to click rotate a couple times until your object is in the right direction. So at this point on your design, you may have seen a couple pieces that are darker blue or even red on your model. The red, which I don't have on here, indicates that one of the cuts that you will be making, so part of the design you have, won't work because of an error in the cutting process. You should not have any red on your design, or else. The blue, though, is not too big a deal as long as there's not a whole lot of it. So you see this dark blue like on the edge of the tail? What that means is nothing is holding that object in place, so it will just fall off of your design. A little bit of blue's okay. Like something like this would be alright. But if the whole tail was blue, you might want to reconsider your construction technique and make it look, fix it, maybe resize it. There's a lot of different stuff you can do so that it's not quite as blue. Incidentally, the smaller your object is, the more likely there are to be blue parts. The ears are mostly blue in your Rhino, is that okay? It's okay, because you are not going to be cutting or laser cutting this one out. What's cool is that if you wanted to do it on your own time, you could print out a sheet of paper and assemble it that way. But since this is just sort of a practice, it's okay if it's blue. And if you want to try changing your slice direction, that could also help. I'm not sure, I didn't actually test it out with the Rhino. But if the ears are probably similar to the T-Rex's hands, and they're both blue as well. What does the red parts mean? The red parts mean that there's a sort of an error in cutting the slices. You'd probably want to change your design either in size or the sheet of paper size to get rid of the red parts. What are you going to actually print? I'm not sure about y'all's class because yours is a little bit different than mine is in Raleigh. In Raleigh, we were going to print our own designs. I'm not sure about the status of the laser cutter over in Iowa though, so I can't guarantee anything for y'all, which I'm sorry that I can't. But I think it's going to be something of your own design if it's anything like in Raleigh. And that said, it's not like we have to print this. You can print some on your own and design it as well, or build it rather, as well. But our goal was to use the laser cutter to cut cardboard and assemble that. So I think it's still pretty cool stuff. I think that y'all do have some sort of access to Laser Cutter. I would hope so, at least. So we did that. Alright, the next thing I'm going to go over is all this stuff over here on the right side of your screen. I know I mentioned briefly about the sheets and the parts. So the design I have here would require 3 sheets of paper and require 120 parts to be assembled. Now keep in mind that my sheets of paper are enormous. The B1 paper that I selected for you is about 4 feet by 2 feet width and length. So this is going to be a very big dinosaur. If you make your dinosaur smaller though, or use smaller sheets of paper, you might have more sheets or more parts. It's really a matter of trial and error. But what that is on your right side of your screen, it'll keep track of how your sheets will be cut, how many sheets will be cut, or how your sheets, how you will have to print out your sheets. So like I said, you can use just a normal printer to print this model out. But remember, you will have to cut out every single little bit perfectly to make it look like this. The laser cutter takes out that whole issue. It'll just straight up cut these designs out, leaving you to only assemble it. So just keep that in mind. You'll also see on these pieces of paper, or sorry, on these models, there are some numbers on them. So if you click on one, 19.1, 18.1, all sorts of different numbers and hyphens and crazy stuff like that. So the first number is actually the step in your assembly process that you will be assembling that piece. So we will need to click on Assembly Steps right under, or it's 2 options underneath Slice Direction. And then take a look at our screen. We'll notice first that our T-Rex or Rhino or whatever will turn brown. If we look at the bottom of our screen, the leftmost option is cardboard. You can actually choose what material your object's made of. I'm just doing cardboard because it's the default option. Right next to that there is a slider, which, if you slide it back and forth, you can actually see this be printed or be built in real time. So step by step, they'll all show up which part you're using. It's really fascinating to watch it assemble itself. As you move the slider, take a look at the right side of your screen where all your sheets are. The part that is active, the part that is being assembled at that step, will light up. So it's very handy, handy to use if you want to do this in real life. You can use that to sort of guide you. I will forewarn you though that sometimes these slices are a little bit off. If they do get off, All you have to do really is to press any other button in your options menu on the left hand side, and it should get back on track. I'm not sure why that happens. This is a free software, so they don't do quite as many updates as they should, I feel like, but for the most part, they're pretty spot on. You also may notice that some of these items have a hyphen and another number after them. This is kind of weird, isn't it? Any ideas why they would have that? Any ideas why these hyphens would be around? We know the first number corresponds with the step that we assemble it, but what are these hyphens? If you have any idea, you can go ahead and answer, and if you don't, I'll tell you in a second anyway. No ideas what these could be? Alright, and that's okay. What these mean is that sometimes when you slice an object, all of your pieces contained within the slice are not going to be connected. They will all be attached to your total object in that step, but you will need to separately connect them. So 10-1, 10-2, and 10-3 may look like three different pieces, but they are part of the same slice, so we will need to put them all together at that time. So a little bit weird to think about, but that is how it is. So at this point, we have a design that we could theoretically print on a printer and assemble and have a really cool T-Rex. But we want to get the plans for it, so it'll make it a little bit easier for us. There's actually an icon underneath the assembly steps called Get Plans. And if we click on it, we will see all of our sheets appear with all of the items that we are going to assemble. At the bottom of your screen, you'll see a couple options. File type, which you want to be EPS. In, which is grayed out, so you're not going to worry about that. Export, and print. Now we would click on print if we had a printer that was capable of producing 4 foot by 2 foot flat pages. So we're going to want to click on export, but I had some issues with export earlier, specifically with this here. The first time I did this lesson, I did not have to sign in or anything. But the second and this time that I've done this lesson, it's telling me to log in. You more than likely created an Autodesk ID when you downloaded 123D Design. And if you did, great. You could just type in your email password, log in, continue on from there. But some of you will have to sign up. If you're not 13 yet, do ask your parents. Create an or type in your email and a password that you'll remember, and hit create account. I'm not sure why that it decided to be so weird the second time I did this, because there was none of this the first time. The reason I'm having you do it this way instead of going to File and Save as you normally would, and if you have a Facebook, yeah, you can sign in with Facebook too. The thing is, though, there's a difference between the export option here and the save option up here. The save option will just save that you have a dinosaur you sliced up, and maybe it'll save the sheets too. But the export option is a little bit different. It actually will save all of these sheets, as well as a step-by-step explanation of the plans to build this. So in general, you will want to use export if you have something that you want to print and eventually create. If you didn't have this issue where it goes to the weird sign-in page, great. Go ahead and and save it as something you'll remember. And save it. Notice that it will save as a zip file, which will just contain all the sheets and all the assembly instructions. So you'll in general want to do it this way. So with those instructions you saved, you can print it out, making sure it's on the right size sheet of paper. Cut it on out, and build it with glue and pins. And that's all you have to do. I know it seems like a lot, but it's really easy to get the hang of. Now that said, I gave you an STL file to use this time, but there's all sorts of different places on the internet that you can find more files that you can work with. How do you save it as a .zip file? It should automatically save it as a .zip file, so let me see if... Let me see what happens when I do this. Give me 1 second. What should happen once you sign in, or don't, you'll see one of the Save As pop-ups happen on your screen. Once you type in the file name, underneath you will see it save as type zip files. And you're saying it saves as a .3D.mk file. That's what happens when you go to File and then Save. You actually want to click on Get Plans and then Export. So that said, if you want to find another project that you can mess around with, there's this wonderful website called Thingiverse, which serves as a repository of a bunch of different designs that people have made. They let you save a copy of their design and mess with it to your heart's content. So you can actually download one of their files and open it up in 123D Make and print it from there. So it's pretty handy. You can upload your own files if you're 13 or your parents have your permission or whatever. But 123D makes a really cool software, and I hope that you will use it in the future. So I know I'm ending about a minute early. I'm sure that you all won't complain. Does anybody have any questions on what we've done today? Because if you don't have questions, you're free to leave. Thanks a bunch for coming out today, and I hope Mr. D will be back on Wednesday to give you a good lesson in a good way. All right. Thanks a bunch, folks. I'll upload the